In this exercise, we're going to be considering functions. So, in our first introduction line, I say it is often convenient to express the Cartesian coordinates in terms of a third variable, usually t. We're going to be doing t as representing time throughout this chapter. So, if we had an axis, like I have drawn there, we have our x direction going horizontally and our y direction going vertically. Normally, if I had a point on that axis, I would represent that point by an x value and a y value. So that point I'm going to call P, has the coordinates x, y. What we're doing here though is we're saying that x is going to be a function of time and y is going to be a function of time. I've called x is equaling ft and y is equaling gt, which means then the coordinates of that point would be ft, gt, where t was a particular value of time. Earlier on in the year, you studied position vectors. The position vector r was equal to its horizontal component we referred to as x plus the y component we referred to as j. So I'm going to mark those unit vectors in on my axes. I is going horizontally, j is going vertically. Now we've said the x ordinate is going to be represented by the function of time ft, so I can say my position vector r is equal to x is a function of time ft in the I direction plus y, which is gt, a function of time in the j direction. Now, it is often very common to now write that position vector itself as a function of time. So I'm just changing the notation so you're familiar with different types of notation. Similarly, this can be done if we were looking at 3 dimensions where we had x, y, and z. So x would be a function of time, y is a function of time, and z I'm going to write as a function of time. So the position vector there would be function of time in the I direction plus function of time in the j direction plus the function of time in the k direction. Remembering k was the 3rd dimension we have used earlier on in the year.